There's the H there, right?
Yeah, there's the AH, but what happens?
See that arrow right there?
Oh, so it's water and it leaves.
Guys,
do you smell that?
hurry up.
In 1,000 feet.
Let's go.
That's what that smell was.
I wonder what makes it smell so bad. This is our organic chemistry project on trimethylamine and trimethylamine oxide, where we talk about the properties as well as the reactions and even the applications of TMA and TMAO, such as why fish smell so bad. I'm Manila.
I'm Isaac.
I'm Owen.
And I'm Ryan.
So this is the compound we are doing our project on, trimethylamine, otherwise known as TMA. You can tell in the image that it is a nitrogen attached to 3 methyl groups, which makes this compound a tertiary amine. It has very similar properties to ammonia, NH3, and that's especially in high concentrations. It's when it acts the most similar. It even smells like ammonia in high concentrations. TMA acts as a Lewis base, and that is because of that free pair of electrons hanging out there at the top. TMA has a distinctive fishy odor when it is present in lower concentrations. The compound itself is easily volatilized, so it's just like ammonia, where it has a very distinct smell. It's just that in very high concentrations, it smells like ammonia, and it'll burn your nose hairs off, which would not be that pleasant. TMA is synthesized by animals, which is actually the microbes that live inside animals, from choline, which is a nutrient, and carnitine, by cleaving a CN bond. And so at the top in that A reaction in the top right, you can see choline, which through an anaerobic microbial mechanism cleaves a CN bond and creates trimethylamine, or TMA. TMA is also used in the synthesis of dyes, and it has a boiling point of 3 to 7 degrees Celsius or 37 to 44 degrees Fahrenheit, which is how, that's proving how it's so easily volatilized. And because TMA is a Lewis base, it does acid-base chemistry. And what better acid to demonstrate this than a carboxylic acid, which is an acid. The pKa of this acetic acid is 4.76. The pKa of trimethylammonium is 9.8. And so the equilibrium constant for this reaction is 10 to the power of whatever the pKa of the product is minus the pKa of the reactant, which gives this KEQ equal to 10 to the positive 5.04, which means that the products are favored.
Now you might be wondering, how is TMAO formed? And it's by our favorite reaction, oxidation. TMA reacts with a peroxide to produce TMAO. This oxidation occurs by the Cope elimination mechanism, and it's the first part of that mechanism. In organisms, enzymes help the reaction proceed from TMA to TMAO. Now here is some more information about the Cope reaction. The Cope reaction was developed by Arthur C. Cope. Cope was born in a small town in Indiana, and he is very famous within the chemistry world. He is known for helping with the effects of the World War II with treatments for mustard gas poisoning as well as anti-malarial drugs. His most famous reaction is the Cope elimination reaction. This reaction is useful in making possible the synthesis of one isomer preponderantly over another. We believe this reaction is the most likely possible pathway for TMA to oxidize to TMAO. This reaction takes place between a tertiary amine reacting with a peroxide. In the first step, the products result in a hydroxide as well as the R3N bound to the OH, with nitrogen having a positive charge. After this, the hydroxide takes away the hydrogen bonded to the oxygen to form R3N bonded to an oxygen, with the oxygen having a negative charge and the nitrogen having a positive charge, as well as water being the other group.
Ryan just told us how we get trimethylene oxide, or TMAO. So what is it? First of all, it's a zwitterion. The nitrogen has a positive charge, while the oxygen has a negative charge. And this has a big impact with the dipole-dipole interactions it's capable of. The intermolecular forces are significantly higher, as can be seen by the boiling point, which goes up by over 200 degrees. This definitely changes how it interacts. So TMA will like to enter the gas phase and leave, while TMAO is much more likely to stay within an organism's water. So there's an enzyme in the human body that oxidizes TMA to make TMAO. And a key thing is that marine organisms are filled with TMAO. Manila is going to cover why this is. But when these organisms die, the TMAO will be reduced to TMA, which is the source of the fishy smell.
So TMAO is actually found in the tissues of marine organisms. It helps them survive the higher pressure that can be found with deeper water. And actually they found that organisms that live further down in the ocean actually have a higher concentration of TMAO in their tissues than ones that are known to live higher in the ocean. And so basically how it works is that at higher pressures, the hydrogen bonds weaken, whereas like at lower pressures, the waters are more of a tetrahedral shape. And so whenever the hydrogen bonds weaken, it causes the water to be more destabilized, and then TMAO can actually help stabilize the water and increase hydrogen bonding because it has that really large dipole moment, and it's a Zitter ion, as Owen mentioned before. And so the TMAO, it stabilizes the proteins in the marine organisms by counteracting the propensity for high pressure to force the water inside the proteins, and it denatures them. And there's a diagram that kind of helps demonstrate this. So the red is the oxygen, whereas the white is the hydrogen, and blue is the nitrogen. And as you can see, the TMAO, it aids in the hydrogen bonding.
Now is the time to stop assuming that a bad-smelling person does not have proper hygiene, especially those people who smell like fish. Those with trimethylamine have no control over their debilitating condition, which is it's debilitating in the sense that it debilitates one's self-esteem. Trimethylamine is most often caused by a mutation in the gene which produces FMO3, which is the enzyme which catalyzes the oxidation of trimethylamine. So it has nothing to do with actions a person takes or their hygiene. They'll do a lot to cover it up, perfumes, colognes, but that is in no part in action. This is almost entirely genetic. If you recall from earlier, TMA is easily volatilized. So when trimethylamine expires off the body through sweat and breath, it carries with it its potent dead fish smell. So that is why someone with trimethylamine smells the way they do. And what is really interesting about this disease is that there is an acute form of it, which one can acquire if they consume an egregious amount of TMA all at once. So much, you have to consume so much that your body cannot oxidize all of that TMA quick enough before the TMA, perspires off the body. So how does one consume that much TMA at once? I will let Owen explain a specific cuisine which has so much TMA where this could happen.
Now, before we dive into Icelandic cuisine, we have to start with some marine biology background. Now, the Greenland shark is the longest living vertebrate, and it lives really deep in the Arctic Ocean. So it's living in pretty extreme conditions. So to survive this, it has a very high TMAO content in its tissues. Now, the high TMAO content is toxic to humans. I read an anecdotal story where they would feed fresh Greenland shark to sled dogs, and they would just kind of get paralyzed and fall over and die. So definitely not something to eat. So the Vikings that settled Iceland utilized microbes to turn it from something that's unsafe to something that's safe. They didn't understand organic chemistry, but they probably discovered this by accident, but they managed to find that if you buried the shark in the soil, there would be the microbes in the soil could convert the TMAO to TMA, which is the same process that an ordinary fish would rot. Now, when it's in this TMA form, some of it can become a vapor and leave, and there's still a lot left. Compared to other food, it's going to have significantly more TMA. So eating a lot of it is not good for you because it still has high urea content, but you're able to move from a food that's unsafe to something that is edible as a small appetizer as part of a larger feast. And that's actually what happens. It's the traditional Icelandic dish of a Karl, and it's a small appetizer that you eat during the Thorablat feast in Iceland. Now, granted, it's not really well liked. The high TMA content gives it a really rough smell, and it's going to taste a lot like ammonia. Anthony Bourdain described it as the single worst, most disgusting, and terrible tasting thing that he'd ever eaten. We just have a couple of acknowledgments to thank for helping our project be so good. Dagan had the great idea of our opening skit, and Dr. Ahad helped us a lot with understanding the mechanisms. Lastly, here are our sources. Thank you so much for listening.